This video is sponsored by PCBWay. Welcome everyone. In this video I'm going to show you my new project. The basis of this project will be this nice board, and the purpose of this project is clearly visible. I made a evaluation or prototyping board which can be used for learning how to use stepper motors and learning how to program stepper motors. And I had a little voting on my YouTube channel, and I had the question whether I should use DRV8825 stepper motor driver or a more modern one, TMC2209. So the result of this voting was obviously that the TMC2209 was more popular. So this board is using that stepper motor driver. And then my idea was the following here. So if we start from the top of the board, you can see this will be the outline of a NEMA 17 motor. And right in the center there will be a AS5600 magnetic encoder. You can see the circuit here. And this small module is configured to be driven by 3.3 volts. So that is that. And then, as I said, the driver will be placed here. It will be a TMC2209, and then the outputs will be here. And down here on this side, there is a buck converter. So this will step down the maximum 28 volts input voltage, which will come in a DC jack, to 3.3 volt. And that will feed the wall circuit. But I did a trick, which is this enable pin. When I assemble the board, you will see it more clearly that actually this pin, which will be a simple jumper pin, can be used to disconnect this 3.3 volt buck converter from all the 3.3 volt devices. And why I did that is because here there will be a STM32F401 microcontroller, and that microcontroller also operates at 3.3 volts. And then, for example, if you want to program the board, you obviously plug it into the USB port of your computer, or you will use ST-Link. And then in that case, you might want to power the board itself, the microcontroller, from the USB. But there would be a conflict if you would power it from the USB and this power supply would also try to power the rest of the components. So the whole board is set up in a way that if you don't have the external power supply enabled, then all the 3.3 volt components, so the magnetic sensor here, the display, the rotary encoder, will be operated from this microcontroller. So it's kind of a smart solution to do it this way. So then we can make sure that we don't burn the components. And then here, LS1 and LS2 are limit switches. So then if you want to program a stepper motor to be used with limit switches, then it can be also done easily because I implemented and integrated two connections for the limit switches. So 3 pins are here, a positive supply, negative supply, and S as signal. And then if you move down here, I have this board, which is a 128 times 64 pixels graphical LCD. So that will be sitting here in this frame. And down here, we will have 2 buttons if we want to control the stepper motor with buttons. But I also made a place for a rotary encoder module. I actually developed a rotary encoder module in my previous video, which you can see up there in the corner. And I made sure that it can be fitted here exactly. So I encourage you to use that module with this. But you can see this circular outline here, which is actually made for another rotary encoder module that you can buy from AliExpress. And basically that's that. So what we will see here is that I will assemble this board, of course, and then I will just put together a minimal setup here just to, let's say, kickstart this project. So this is more like an introductory video, and then we will see how the things work. And once everything works, then I will release more videos using this board and showing how to develop code for the AS5600 magnetic encoder. I already have some videos. Some of them are quite popular. Check it there in the corner. And then of course we will jump to the more important part, which is the TMC2209 stepper motor driver. And you might know this driver from other videos or from other resources, but this is a very good driver because it's very popular in the 3D printing community. It has some features which can make the stepper motor basically silent. So then we will evaluate how silent the stepper motor becomes after using this driver. And then yeah, that's basically it. And if you want to get this nice board, I encourage you to visit the website of the sponsor of this video, PCBWay. I used their services to make this board manufactured, and you can also use their services to either get this board done for your own stepper motor driver project by visiting my project website, or if you have your own project, just go to their website, visit the PCB ordering page, and then just customize your board according to your requirements and send it for manufacturing. And also they have a circuit design contest. So if you have some cool projects, then don't hesitate and go for it. Nominate your project and then make sure that you upload everything. The more you upload and more details you share, the better chances you get to win some valuable prizes. So please go ahead and check out their competition website and have fun while competing with your project. So coming back to the board, it is mostly a mixed board. So here the AS5600 and the 3.3 volt buck regulator are SMD components, and then there is a few other components where I have SMD parts, and then the others, since they are modules, they are through-hole components. So then I will show you how I solder these together in a bit faster way, and then we will go through how this project works. So as you could see, I assembled this nice board, so it has everything, both the SMD components and also the modules, and it's nice and colorful. But then you can also see that I have this stepper motor here, disassembled. I just simply removed its bottom panel, or how it is called. So this was here. And the reason for that is very simple. The reason why I removed the back is that we have this nice diagonally or diametrically magnetized magnet. So the magnetic poles are not on the base plate like on the top and the bottom, but it's on the side, and that makes it possible to be used with the AS5600 magnetic encoder. So what we will do with this magnet is we will try to assemble it together with this shaft. So first I remove this guy because this comes off easily, then we see a better access. So this guy is the shaft, so I just rotate it if I manage, but now it's probably difficult because it's not aligned, because I disassembled it. But you see how it rotates, and you see all the teeth and the coils and so on. But then the most important thing is that this should somehow end up at the very middle. And there is a lucky, or I don't know if it's a lucky thing, but as you can see, the magnet actually pulls up this bearing. But that's very lucky, because when it pulls it up, then it also aligns it, because the diameter of this magnet is just about the same as the diameter of the shaft. I think it's about 5 millimeters. I will measure it and let you know the parameters. So then what I can do, and I will do, is that I will put a drop of super glue just on the shaft, just a little tiny blob, so it will not go here. And once I put that there, I will place the magnet back, something like this, and then align it roughly, just to make it center, and then I release the magnet. So then the magnet will, or the bearing, I will release the bearing, and that will make sure that the magnet is aligned. And then I will just leave it for a while, so the glue can cure. And then I will push back the magnet, and then put back this to the house or casing. But then when I assemble this, instead of using the original bolts to just hold together the casing of the motor, I will use somewhat longer ones, because then the motor, I can demonstrate it with the bottom, will be directly attached to the board. That's the whole purpose of the board. So here, first of all, we see that the wires should face that way. So then you can see this notch that is facing that direction. You can see the connector. And then you can see that if everything is aligned properly, so everything is nicely aligned, then the motor will sit on top of the sensor like this. So if we go to side view, kind of, actually I will put some nylon washers, so then the motor will sit something like this. So there will be a sufficient distance between the magnet and the top of the sensor, and then the board will be completed. So I prepare this thing, and then I'm going to demonstrate it to you. So this is the board, as you can see. This is the completed board. It has all the components assembled, and everything is in place. except a few external modules, for example the limit switches, but this is just the demonstration for the board itself, so we don't care about the limit switch or switches right now. So just to be sure that I introduce everything, I just go through all the parts of this board, and then I will also demonstrate it to you, so you will see it in action and you will see how it can be used and why I designed and built it. So maybe we can start with these features at the bottom. So you can see that we have two buttons. You could see these kind of buttons in my earlier projects with some kind of similar features. So some stepper motor controlling thingy. Here I just wanted to have two individual buttons, for example stop and start, or positive direction, negative direction, or so on. You can assign any kind of behavior to them. That's the purpose of the whole board, to develop stuff, so that you can do it as you wish. And then we have this rotary encoder module, as you can see. I made this module in my previous video, check it out. And there is nothing extra to tell about it. We can rotate this, as you can see, and it has a button, so we can use it as a switch. And in this current demonstration I will just rely on this rotary encoder and its switch, and you will see how things work. And then we have this nice display. This is a graphical LCD. There is nothing interesting about it. I will just use it to print some information on it, and that's all. So yeah, this is just to get some feedback. And then the brain of this thing is this STM32F401 CCU6 microcontroller. So this takes care about everything basically. So yeah, there's nothing to talk about. Maybe what I should mention is that I always use these 4 pins. These are the ST-Link pins. So I'm using an ST-Link module to program the microcontroller, and I'm using right now the Arduino IDE with the STM32 framework, and it's very easy to program it. But then when it comes to communication, of course, we can use the nice USB-C connection, so that's nice. And then we have the, let's say, main character here is the TMC2209 motor driver. The demo is implemented in a way that I use some traditional step and direction control, but I also use the UART port, so the serial port, to control the stepper motor. So both functions are implemented, but in a very simplistic way. And then these two guys here, LS1, LS2, just some limit switches. So we have positive and negative voltage connections. So let's say 5 volt or 3.3 volt and ground, and then S as a signal. So that's connected to one of the GPIO pins here. And then here we have the motor connection, and you can see that I chose a very nice color terminal here. And you can see that the wires are flipped. And the reason for that is because actually the output of this motor controller is somewhat funny, and I did not want to make a large mess on my board. So you can see that we have M2A, and then an M2B belongs to that. So M2A and M2B goes to one coil of the stepper motor, and then M1A and M1B is another coil of the stepper motor. So that's why the wires are kind of twisted, because then one pair is the black and green and the other pair is the red and the blue. So that's what you can see here. And then on this side we have the, let's call it, power supply. Well, the power supply is an external power supply with a DC barrel jack, but then this is the voltage regulator. So maximum 28 volts come in, and that 28 volts is actually the limitation of this guy here, the stepper motor driver, because the stepper motor driver is actually directly driven from this input, but then the rest of the board can be powered with this module here, which is a step down controller or converter or buck converter. So then it takes maximum 28 volts, and then it converts it to 3.3 volts, which powers everything all around the board. And here, this enable pin is actually a jumper. So now there is no connection from the 3.3 volt output towards the rest of the board, but then everything 3.3 volt is powered by the microcontroller. And that only can happen if the microcontroller is powered by the USB connection. And that's the purpose of this pin here, or jumper here, is that it helps us to avoid simultaneously power everything from USB through the microcontroller and from this buck converter. So if I decide to use an external power supply, but I want to have my device connected to the USB port, then I just remove this enable jumper. So then there will be no conflict. And when I use this as a standalone unit, just from an external power supply, and I relay on the display, then I just put this back. And now the whole 3.3 volt network is powered by this converter here. And then I have a NEMA 17 pancake stepper motor here. You can see that this is a smaller form factor. And then right here, you can see that that is the AS5600 chip. And then it is surrounded by a few capacitors and resistors. But then that is sitting just under the magnet that I installed. You could see it, how it was done. And then I used a few nylon washers just to create enough gap between the magnet and the top of the chip. So then that's the board. And then let's power it up to see how it behaves. So before powering it up, let me do two things. First, I have this zip tie, and I will just put this on the shaft so it will be more apparent when it turns, because the shaft is not really visible when it rotates. Maybe I should hold it like this. And then another thing is that we have this DC jack here, and I will just simply plug it in. So then this goes to an external power supply, which is just a laboratory power supply right now. But then this jack, this guy here, allows us to power this from any kind of external power supply. So a wall adapter is perfect for this. But I would recommend to go close to, let's say, 24 volts, because the higher the voltage, the more efficient, or yeah, efficient is probably not the best word, but let's use it, more efficient the stepper motor becomes. But for this demonstration and let's say development, where you just want to implement some kind of behavior, it's perfectly fine to use it from a 9 volt or 12 volt power supply. So a small, let's say 1 or 2 amps wall wart is perfectly fine to power the wall board. So since things will happen after I power up this, I will just explain what will happen. So as I said, the stepper motor driver can be driven in two different ways. One is that it has the step and direction pins, and if you toggle those pins, or more specifically, you toggle the step pins, then you can drive the motor. So then I then I pull the step pin, and then the motor will move in one direction, and then I change the micro stepping, and then it will move in the other direction. And I go through all the possible micro stepping options and do this back and forth motion. And then I will try to make it work in a simple way where I really toggle the pins. So I'm not using any libraries for that function. I just use the digital write function in the Arduino code. But then in the next step, I use the Excel stepper library and basically do a similar thing. So tell the motor to move a certain amount of steps by using the library. And then the motor will hopefully react to some to this somehow. And then the third option will be that I'm sending serial commands to the motor driver, and that will be just simply setting the motor speed to a value, and I will just not change it for 5 seconds. So for 5 seconds the motor will move in a certain direction, and then I will stop the motor and move in the other direction for another 5 seconds. And then everything stops. I initialize the magnetic encoder under the motor, so we will have some kind of 0 position. The stepper motor's position based on the Axel stepper library will be also zeroed, and then I will be able to use the rotary encoder to further move the motor. So let me power this up, and let's see how it behaves. So as you can see, everything worked fine. And now what we are seeing is that we have the total angle. So this can go beyond 360 degrees. This is the total rotation in like absolute coordinates. So if I go backwards in the counterclockwise direction, then this number becomes negative. If I do 2 turns backwards, then this number should be very close to 720 because it's expressed in degrees. Then the absolute is just the magnet's position in the 360 degrees circle. So then once I go beyond 359 point something something, then it will become 0, 1, 2, and so on and so on if I keep rotating in the same direction. And the encoder is just that if I click the encoder once, then this goes up. So basically this is just a counter based on the number of clicks coming from the encoder. And then what this will do is that whenever I set this to a certain number, then if I multiply this number by 90, that will be the target distance for the motor. So now, for example, if I would press the button now on the rotary encoder, then this should do half a turn, and then the total angle and the absolute value also at this specific scenario should be 180. So before forgetting what I explained, I just press this button and we'll see if it will end up at somewhere around 180. You can see that we have some uncertainty here because I did not invest too much time to polish the code for the demonstration. So yeah, that's good enough, I would say. So now we went half a circle, and according to the magnetic sensor, we also went 179 degrees. So that's good enough. And if I move to the 1, that's actually the absolute value. So this should jump to 90 degrees. Then if I'm not wrong, then this zip tie should come back 90 degrees. And then also the values, the position values according to the magnetic sensor under the motor should go to 90 degrees. So let's see. So yeah, that's 90-ish. One more thing, I haven't spent too much time to align the motor very perfectly. So you can see that even if I bump into the shaft, I can move the motor's shaft. So yeah, but this video is not about those nuances, but it's more about showing the board. So if I go to 3, that should be 270. So we go clockwise and we'll end up somewhere up here. So let's see that. Yeah, and 270-ish. I moved the shaft manually, so that was of course not accounted for. But you can see that everything moves quite nicely. But there is one more thing that I wanted to show you, and that is actually here. So you can see that we have a diode right there, which is just indicating that the power is on. So it's a red diode or LED, a light emitting diode. But you can see that in fact we have a V sub here, which is a tab for the supply voltage, GND, which is the ground, and plus 3.3 volt. So the purpose of them is just to check if we really have the proper voltages all around the circuit. So I move this a bit aside, let's say here, and then I bring in a multimeter. So then this is the probe, or pair of probes. So then I just simply tap on the ground with the black probe and then 3.3 here. And you can see that this is the output voltage of the voltage regulator. And then I try to go to the other side just to keep showing the ground probe. And then V sub. And this is the input voltage. So that's 9.35. That is the voltage coming from my laboratory power supply. So yeah, this is just some nice feature that is worth to mention. So yeah, as the first introduction video, I think this is the wall stuff that I wanted to show. So the purpose of this board is basically to provide some development platform for, let's say, learning how to code driving stepper motors, but also learning how to code for the magnetic encoder, because in most of the cases those magnetic encoders will end up somewhere on the shaft of a stepper motor, for example. So I think it's a good idea to combine these two together. And then also, many cases, I know it from the comments or the emails that I get, people are interested in installing limit switches. So therefore I have two. So for example, if you have a linear rail, you can put it at the beginning and at the end of the rail. So you can have, let's say, emergency switches. So you can develop the code for that. And then we have this big display. So we can develop code for the display that gives us feedback, how the motor behaves, how the encoder behaves, and so on. And then with the two individual buttons and the rotary encoder, you can also kind of practice and learn how to code a menu, for example, or like I made this very, very simplistic stuff that, for example, by changing the encoder or rotating the encoder, I change this number, and then by pressing the button, I can instruct the motor to move somewhere. And then, yeah, that's the whole purpose of this board. And I purposely chose this microcontroller because it's a very powerful one. So it has a high enough, let's say, clock on its in its CPU. So that's very nice because then we can run a lot of tasks with it. And also it has a lot of pins, which is better than, for example, an Arduino Nano. And it's relatively cheap. So if you go to my website and check out the links under the parts and tools section, you will find this microcontroller on AliExpress, and you will see that it costs peanuts. And also, most of these parts can be found on my website. So check the link in the description, because I wrote an article about this with some extra pictures and stuff, extra information. And you will also find all the relevant parts, including my previous project for this nice little encoder module. So you can not only just build this board, but if you are interested in rotary encoders with a active debouncing component, then you can also make this. And last but not least, all these things like this board here and also the board, which is now supporting all these circuits, can be found on my PCBWay project page. So I also encourage you to visit that link in the description, which will forward you to my PCBWay project page. And if you are interested in having the rotary encoder module or this stepper motor development platform, then I just encourage you to head over to PCBWay's website and then order it from them, because I published everything there relatively carefully. So I provided a lot of details, bill of materials, and all those goodies. So you will be able to get your own board and build your own development platform. And then in the future, let's say near future, I will keep developing codes, and for example keep developing and implementing code for this stepper motor driver, because it's a very powerful stepper motor driver and it's very useful. So if you haven't subscribed to my channel, please consider subscribing, because you will get a very huge amount of stepper motor and encoder related content in the future. And those will be all based on this development platform. So if you happen to be interested in these things, it's a good idea to get this platform, and then you can just follow my videos, how I write the code and so on, and you can use it for your projects. So I hope that this video was useful to you. I hope you found it interesting and you learned something, and see you in the next video.